Again, thanks for being here, and just to recollect the session that we had. So what I'm going to take now, we'll have some inkling on the challenges that we face into the future, and to just hear about the challenges of the PSU banks and the way the digitization happens in the rural segment. It's really an eye opener. I mean, and also to come out with a final solution. So that's really a laudatory task, which we don't realize how they actually do it on the ground. Sometimes we feel that it's probably too easy and people are not working out, but this is really something amazing. So to talk about Seagate, this was a small video that we created on the 40th anniversary, which is today, and what we plan to do into the future. So to start with, my name is Vivek Upman, and I manage Seagate's enterprise business for South Asia. The reason why Seagate is here, we usually go to partners conferences, not usually to the delegates or to the end users, is that we have changed our approach now. We have been an OEM supplier, but now with the new trends coming up in the market, particularly edge compute, we are now want to address challenges and solutions directly to end users and business organizations like you. So what I'll try to highlight in this session is what is edge compute, or what is edge, and what are the challenges associated with it when the infrastructure supporting the edge will rise. Make no mistake, in next 2-3 years, this is going to define a lot of applications, lot of markets, and lot of challenges as well. So we'll start with this. We have already seen the video, and where we talk about more of the data sphere. That's a term that Seagate has brought into the market. And what we try to understand over the last 30-40 years is that there's a data landscape, right from the time of 1970s till we are here. So many senior executives who are here will remember something like Industry 1.0. That's what we call those times when we were talking about mainframe computers, when the digitization started or basic software translation started. The world started to realize the importance of data, but still it just started and it had a lot of limitations. Then we moved on to something called IT 2.0. That is when the client-server model came and the PC workstation started. A lot of data started to be created, but again, at the end of it, it was still limited to a local storage, which eventually pushed into the age that we are in because of virtualization, the cloud computing, the mobile device computing, and we had exabytes of data, the apps, they started to come, a lot of business intelligence, but still, in this age of IT 3.0, we still have a question that, are we able to harness the data the way we want, in a way, and intelligent information could be put to right use? That is where the edge computing will define what we call it IT 4.0, Industry 4.0. Now this will be driven by a high-speed fiber or a 5G enablement, which will make the data active and not passive. So artificial intelligence will do predictive analysis, and IoT will then connect everything and throw up millions and trillions of devices. That is what the session is going to be about. I hope I'm able to translate that vision that the world is going to see in the next 5 years. So when we talk about the amount of data that is going to be created, trillions of devices will be there, everything will become a sensor in itself. So what is the data that we are looking which will be created going forward? So Seagate, in collaboration with IDC globally, created this Data Age 2025 report, which tells you how much data will be created till 2025. So you can see around 175 zettabytes of data will be created. Around 33 zettabytes were already created in 2018. So this is the amount of data that we are talking about, the whole data sphere. Now what is 1 zettabyte? Something like 1 billion terabytes or 1 trillion gigabytes. Whatever it is humongous and it is out there. We are creating it on a daily basis. An important thing is that you guys are creating something like 30% of it, and that shift will be around 60%. So the entire 175 zettabytes will be created. Out of that, 60% will be created by enterprises. So that is the kind of stake that enterprises will have, and we see the movement of data going towards enterprises from the client. So how that happens is, this is the Seagate data sphere that we call it. Currently we have something called the endpoints. My smartwatch, my mobile phone, my tabs, my card. So anything that releases the data and could be put to use becomes the endpoints, and finally the data moves to the core or the hyperscale data center for data activation, for data storage, and finally sending back for intelligent action to be taken. That's where the problem rises, and that's where the edge will come into play. When we say edge computing, what is this edge? Which will come between this endpoints and the core. So if you Google right now, you will find this is the kind of search results which edge compute throws up. So this is something which is very popular now, and a lot of applications are already being developed in the mature markets, and it will come very strongly in the Indian subcontinent as well. We have been involved in a few of the 5G trials that goes with the telecom, so we can see that this infrastructure is going to come up thick and fast. So let's look at what is the edge. We keep hearing about edge, and the terms and the solutions that come up, but let's try and understand what is this edge. The best way is to understand what is not the edge. So we did speak about the endpoints, the core, which is the current infrastructure that we have. So edge is not a centralized cloud that we have of the telco data centers. So edge is defined by the data activation, data compute, and the data storage that happens in between the sensors, the endpoint, and the final resting place, that is the hyperscale cloud. So from a centralized hyperscale closer to the data source. So what essentially edge computing is trying to do is, it will make the processing of the data near to the sources rather than traveling all the distance to have the data analyzed and sending back important data or the relevant data for action, saving the time. That is where the challenge comes. When the data comes back, do we have enough bandwidth or the strength so that the data comes back in time to take that intelligent action? Whether it is in smart agriculture or in terms of logistics and transport that we spoke about, this will take an important decision-making role once this true potential of 5G or high-speed fiber is realized. So this is what is the edge. That is data activation, data compute, and data storage. Now the question comes is, why is this edge emerging? If everything was going good, what is the reason why edge should emerge? There are basically 4 reasons that we can come to. One is the low latency expectation. Not just that you want the data to be fast, but for some of your specific applications, again for the logistic relation, you'd want the data to come back in a defined framework, otherwise the usage of it will make no sense. So that is one of the reasons. Then there is high data volume, cost, and the compliance. So if we talk about the low latency expectation, it is that when I capture the data and I send to the processing center, it should not take so much time that it comes back, and by that time the action misses out on what is required to be produced. Whether it is about smart agriculture, drone applications, logistics, smart surveillance, low latency is the most important aspect or the backbone which can give you the desired results. So this is which we try to explain why it is important to have the low latency expectations. Otherwise, edge will not make any sense, whether it is a high-speed fiber or 5G, high data volume. So we found out that even with a 4G connection, the kind of data that we have, sometimes there is a lot of clog in the network. You don't get that kind of a speed unless until you move out of a certain area and you start feeling that the data is better. So the kind of bandwidth that we have is cluttered right now, and it doesn't allow that kind of a advantage in terms of getting the real-time applications to play. So that is one of the reasons why people are looking towards 5G or high-speed fiber, because it doesn't really give them what the desired advantages. Cost, I won't go back too much into the cost, because right now the focus is getting the qualitative framework. People are ready to pay the amount for a qualitative framework, but this remains an important consideration. Compliance is going to be one key challenge, because I don't think we envisaged 3-4 years back social media giants addressing the parliament or being asked for questioning regarding data challenges. So when we move to a newer technology, the question would be, can it address the current security frameworks, or can it provide something better? There is no final guarantee of any security. There are a lot of people from security industry, they will understand. So can it address those challenges going on? So how will the edge manifest? So we try to understand what is edge, what is not the edge, and what are the reasons why the edge is emerging. Now once the edge has emerged, how will it manifest itself? So we would know that edge is made up of all these sensors that coming up and throws the data. So every application will move differently, but they have three defined simple processes. That how the data is captured, how it is moved to the edge, and finally what is its resting place. This is how every application will have in its own way these processes which will be aligned. So where will the edge live? Once the movement is clear, the telcos will have the first mover advantage because they already have their the data centers, their base stations, their switch centers. These will act as the base stations or the micro modular data centers where you will have this new setup of the edge, along with private data centers, which again are currently being hosted by those telcos. So we know most of the telcos hold these big cloud service providers, at least in India, whether it is Amazon or Microsoft Azure. It's held by most of the Indian data center companies, or for something like NTT NetMagic or ESDS or Control S. So we know that eventually the telco infrastructure will not only take the lead, will continue to build upon this infrastructure. Now let's look at the key difference which we talked about 4G, and why 4G is not enough if you are talking about one of the factors which will drive the change. In 4G, the frequencies are cluttered, and at the same time there is limitation of amount of devices that could be there in a particular, let's say, 1 square mile. In 5G, there is no such limitation. It almost supports 1 million devices per square mile. So we are talking about trillions of devices near a base station. So that is a kind of movement that will come with 5G. The slowness of 4G comes with the inherent nature. The data travels longer distances but slower. So obviously it takes time to come back. In 5G, the data movement is at a shorter targeted distance but very fast, and that is where the edge will manifest itself. Now what will happen is, if we are talking about that this kind of an emergence will be there, this kind of infrastructure will be there, millions and trillions of devices will be there, a lot of applications will come up, a lot of challenges will come up as well. Because is our infrastructure good enough to hold that kind of data once the high-speed fiber of the 5G comes up, even in defined locations to start with? So this is the kind of movement that we'll see. Currently, it is a business consumer to device kind of a communication. With 5G, it will completely overwhelm the current setup that we have. So we are really looking at trillions of devices which will come into play. Now, we'll move truly into M2M communications, but with this movement will bring itself new challenges, which I just spoke about. We'll need more base stations now to comply with more and more data that is coming in. And what we have at the backend connecting is an IP backend tunnel. So there could be, and there will be a scenario where if we allow all the data to move in, it will overwhelm the backend IT network or the IP network. Now, so this will give another rise to another business case which we call as edge data analysis. That at the edge level, we do filter the data which needs to send back. We don't send all the data back to the cloud for its final resting place. So this is where the data storage and the data analysis also come into play. So the amount of application that will come once the 5G or the high-speed fiber starts to come up, we don't even know the kind of application that will start coming up in our own organizations and to support what the market will demand. Now this was a slide which I wanted to talk about without showing anything. It could be kind of an open discussion that what could be the best use cases for the edge. In Western markets we keep hearing about autonomous vehicles where it really makes sense, where the car itself is a sensor. There are a lot of things on the car where it continuously emits the data to a nearby micro modular data center wherever it travels regarding the amount of traffic which is there, amount of pedestrians that are moving, when to apply the brakes. So they are dependent on critical information coming back from the data that is generating. That it makes perfect sense that you need 5G enablement there. What about India in terms of Indian subcontinent? What could be those application or use cases which can really make sense? Now in current scenario, what we could think of is what was spoken about related to digitization and the logistics. So logistics is one of the framework along with smart or productive manufacturing, where the current robotics or the current production facility can be built in with AI, predictive analysis, and then it takes advantage of the edge in terms of decision making at that instant, rather than waiting for the data to be collected, fed back into the system, and then the final act takes place. So what we see going forward is that from Indian perspective, we'll have smart surveillance, which will really demand stronger edge applications, smart agriculture drone applications, and the logistics area, which will really call for the industry to provide right kind of edge solutions into the future. So these are the things that we thought could be making a good sense for you guys to think over and probably create solutions for in the market for your own companies and for the others as well. So now talking about the solutions to the edge. So I'm sure not many of you would have thought that Seagate, which is a hard drive disk maker from last 40 years, will be talking about the edge. Now this is a kind of a acceptable perception because that's the way we have been working. We have been mostly working behind the scenes. So Seagate has been a storage system provider to the OEMs. You name the biggest OEMs, they have been using our JBOD, our SAN, and our application platforms. Most of them are white labeling those solutions. Now why we are talking to you directly? Because we are used to talking to OEMs always as partnership. Because now with emerging edge scenario, we are looking that we need to be more intimate and closer to the end users to understand what kind of solutions that we need to create. So this is an effort to kind of give you an overview after we have made an understanding about what the edge is. So Seagate Systems, we provide SAN systems, JBOD, and application platform from many years now. This is not the first time. So we have been an OEM supplier, and now we are coming directly to organizations like you who can take advantage. So these are our brands. Exhaust is our enterprise hard disk drive, which goes in all the storage systems that come out in the market. Nitro is our enterprise SSD. And finally, Seagate Systems. So why we are better in terms of what others could provide? Simple, there is no dependency on anyone. These are all dual controller system. The controllers are owned and manufactured by Seagate. The chassis, the PSUs, the fans are manufactured by Seagate. The hard disk drive, the SSDs are manufactured by Seagate. Even the operating system, the real store operating system is of Seagate, and Seagate owns the Seagate firmware as well. So it reduces, there is no dependency. So obviously the kind of hardening that we provide, no one else can match in the market to these solutions which are already there in the market. Now to throw up a brief understanding about how many modular storage that we have, I won't go too much into detail. I'll be happy to connect with you guys after this session if anyone would be interested to have a look at this. This is our 2U12, which can stack up to 192 terabytes. All are dual control. Then this is 2U24, which is stacking up to 384 terabytes. These are all for media entertainment, for your private cloud, for your central SAN storage. This is something which could be easily considered. Now we can go with something like a mammoth box. This is a 1.7 petabyte system. These are all BIS compliant now, and we are shipping into India. So every slot is with minimum 16 TB drive, which makes up to 1.7 petabyte kind of a storage. Now, why this is better? Because it is future proof. You don't have to rip and replace. It comes with an upgradation automatically. So we will be launching 20 terabyte drive. We've launched 16 TB last quarter. Next quarter we'll be launching 18 and 20 TB drive, and this will be taking care of that. You don't need to change the box for that. Now this again is a very important product which you guys will be interested. This is a application platform. You can use your own SDS platform as well. This comes with a compute and storage. So it stacks in 100 drives. It includes 96 HDD and 4 SSDs. So this typically works for a private cloud scenario that you wish to build for your applications or kind of a central storage. Finally, we have our all flash arrays for your screen, for performance hungry applications. So this is a 2U24 which every slot can take care of something like 15 terabyte. So we have an SSD, SAS SSD, which the maximum capacity is of 15 terabytes. So this is the kind of performance it throws up in 1 millisecond. So this is the overview which I wanted to give, what Seagate is, what we think edge is, how the edge will manifest itself, and what is the solution along with the use cases that Seagate thinks in the next 4 or 5 years which will be driving the market. So as we said, the roadmap that we have in terms of the data age and the industry IT 4.0, what we did was in IT 2.0, Seagate was working directly with the OEM partners. In IT 3.0, that is this time, along with supplying of the OEM partners, we also work with Amazon, Oracle, Alibaba, all these cloud platforms to ship drives directly to them. In IT 4.0, we want to work with organizations directly simply because the scenarios are going to be changed. Disruption, we've already seen the biggest disruption coming in, but this is going to be the technology disruption, which is the need of the hour simply because of the limitations of the present infrastructure that we have. What we see next 2 years will fundamentally change the role of the application that we have. It will be machine-to-machine communication. So thank you. If you have any questions with me, I'll be happy to answer any of your questions related to Edge, related to Seagate systems. Anyone has a question? So I hope we did manage to understand what the Edge is, right? I thought this was a relevant topic going into the future, rather than just be a product session. And because you guys are end users, I wanted to make sure that Seagate vision of Edge is clearly demonstrated. So if there are no more questions or there are no questions at all, I'll move out from here. Thank you so much for being such a nice audience.